We are now going to talk about arithmetic series, which is different than an arithmetic sequence. So a sequence is just a list of numbers, but a series is going to be the sum of the terms of that sequence. So for example, if we have the numbers 1, 3, 5, 7, etc., all the way up to 97, that's an arithmetic sequence. However, if we were going to add up all those numbers, 1 plus 3 plus 5 plus 7, that's an arithmetic series. What makes it arithmetic, of course, is that it's a constant ratio. So this are going up by 2. The numbers are increasing by a constant amount. That's what makes it arithmetic. The fact that we're adding makes it a series. The symbol we're going to use, so T44 is the 44th term of the sequence. S44 is going to be essentially the sum of the first 44 terms. So the 44th term of the series is the sum of the first 44 terms. So we're going to come up with a formula. Before we do that, we're going to do kind of a warm-up just to see the technique we're going to use. It's easier to see with actual numbers. So the question is, what is the sum of the first 100 natural numbers? Natural numbers are just the ones that you count. So the sum of the first 100 numbers is 1 plus 2 plus 3 plus 4 plus etc., 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 plus 98 plus 99 plus 100. Now what I could do is I could also write it in the opposite way. So this is the same thing, just written, instead of writing it from 1 to 100, I'm writing it from 100 down to 1. Now why would I do it like that? Well, because we can add these guys up. So what we get is we get two S100s. So 2 times the sum of the first 100 terms is equal to, so 1 plus 100 is 101. And 2 plus 99 is 101. And 3 plus 98 is 101. And 101. And 101. And 101. And 101. Now how many times do we have that? There's 100 numbers, so that's going to add up to 101 100 times. So 2 times the sum of the first 100 numbers is going to be 100 times 101. Or to put it another way, the sum of the first 100 numbers is going to be 100 times 101 divided by 2. I forget what it actually is. It's like 5,000 or so, 5,050. By the way, this is a party trick you could use anytime. If you want to know the sum of the first number, the x number of numbers, you just take the number, multiply it by the one above, divide by 2. So the sum of the first 10 numbers would be 10 times 11 divided by 2, which is 55. Okay, so now we're going to take this technique and we're going to apply it to an arithmetic sequence. And we're going to try to come up with a formula. So an arithmetic sequence is, A is the first term of an arithmetic sequence, and then we add D again, so it's A plus D, A plus 2D, A plus 3D. It ends at the nth term, and 1 before the nth term is D before it, so that's why it's T to the n minus D. Okay, and we're going to do the same trick. So we're going to write all the numbers from beginning to end, and then we're going to write all the numbers from end to beginning. And we're going to add these guys up. So 2 times the sum of the first n numbers, and a plus t to the n is going to be a plus t to the n. And then over here we have, I'll write down another piece of paper. We have a plus d plus tn minus d, which is a plus d plus t to the n minus d. The d's cancel, and you end up with a plus t to the n. So these two also add up to a plus t to the n. And these guys, those are going to cancel, is a plus t to the n. And over here, these cancel, a plus t to the n, and a plus t to the n. how many times are we adding a plus t to the n? Well, we are adding it. There's n terms. So we're adding it n times. So 2Sn is n times a plus t to the n. Or we could divide by 2. So the sum of the first n numbers is going to be n times, and multiply by 2, a plus t to the n. And that's our first formula. Now what we're going to do is we're actually going to play around with that a little bit. Whoops, that's from before. So we know that Sn equals n over 2 a plus t to the n. But the nth term is equal to a plus n minus 1d, and we know this from arithmetic sequences. So what we could do is we could sub this in for t of n over there. And so we're going to get Sn equals n over 2 a plus, and then we're going to sub in a plus n minus 1 d. Okay, maybe I'll make this into a square bracket. So Sn is going to be equal to n over 2, and then a plus a is 2a plus n minus 1 d, and that would be our second formula for the sum of n terms. So just to summarize it, the sum of the first n terms we actually have two formulas, for it. Either Sn is n over 2 times a plus tn, so we use this one when we have the nth term, or the sum of the first n numbers is n over 2, 2a plus n minus 1 d.